Hi, my name is NJ and I'm from Group 2, and today I'll be presenting our project, which is a project called Intrusion Detection Systems Simulator. Basically what we're trying to do is introduce something that can detect an intrusion. Well, it's for security reasons. So in this project we used different embedding system tools. For example, we used this buzzer. This buzzer is supposed to be used as a simulator for an alarm. So basically when a human being is opening the door, it will sound an alarm, and these are lights. The LED light is supposed to simulate the lights. So basically what happens when an intrusion is detected is that the sound of the bell will start sounding, and then there will be lights that will show. We also have the ADXL 345, and the ADXL 345 is supposed to simulate a door. So basically if there is any movement of the ADXL, it will simulate the opening or the closing of the door. And then here we have the camera, the PI camera, and this camera is supposed to simulate an actual camera that is there in security systems. So how do we do this project, and how does this project actually work? In this project we tried to train a model. Basically we used a detection system, and this detection system was from HAR Cascade. If you can just take a look at this, this is our reference point. So in this HAR system they try to use the camera to detect pictures alongside pictures that they have already trained using a model. Now what happens is that they will try to detect the face and then try to match it with different pictures. Now after matching it with different pictures, they try to see how many of the pictures actually match the face that is shown by the camera. The highest number, which is the maximum number of the pictures, or the maximum number that is shown for that particular person, will represent that person. For example, if unknown has maybe six things showing, or maybe NJ has 6 things showing, that means maybe unknown or NJ is the actual person who is reflected in the camera. Now I'm going to do a quick demonstration, but before I do the quick demonstration, I'm going to explain some of the code that we used in our project. Basically in this project we have so many different types of codes, but our main project is done on the human detection pycamera.final py file. Okay, in this py file we try to open the door, and then the ADXL here will simulate the opening and the closing of the door using the status. So if the status of the door is true, that means the door is actually open, but if it is false, then it means that the door is closed, and nothing will happen if the door is actually closed. Now after that happens, we will try to capture the image of the person and also sound the alarm. The alarm, as I mentioned before, will be sounded by the buzzer, and then the lights will be turned on too using the LED lights. Now after that happens, the sounding of the alarm will happen 3 times, because we don't want an alarm sounding the whole night or the whole day. Just as long as someone can hear what is happening, that there's a sound of an alarm, that means there's a certain intrusion happening. So we made it to sound 3 times. So in this part we are just talking about the sounding of the alarm alongside the lights. Okay, and then from there we can check whether this is from a human being or not. Okay, but before we get there, this part will only happen if the human being is actually opening the door. So because the detection algorithm we used can't be able to detect whether it's an animal, it's a human being, it's a keyboard, or it's a mouse using the camera, we will be able to detect that it's a human being. And if it is a human being, if the ID showing on the camera matches a human being, then these things will happen. And then from there we will start capturing a video of the person, and then after we have captured the video of the person and matched the person, we will send a message to the line of the person who actually owns that particular office. Now as I mentioned, we use different codes. We have the pi recognition code, and we have the encode faces code. The encode faces code is supposed to be used to actually train our model, which is like make our algorithm to actually know whose faces these are. But how does that happen? Basically, here we have different folders. In this case, I only have two folders, which is unknown and NJ. So if the person is unknown, their pictures will normally be saved under unknown. And then NJ, in NJ, as you can see here, I have many different pictures which I have used to train the model in order for the model to be able to understand that this face actually matches NJ or not. Okay, going back to the code again. And then we have the PI recognition. PI recognition is also some part of the code was adopted from online GitHub, and then from here we are able to see, you see this part is the part for actually sending a message to line. But how does that happen? It happens through this token. This part here shows my line token, and to generate my line token, I have to have an account. And here, as you can see, I just copied my line token and then just placed it in this code, because this code is available in GitHub online. Okay, now let us do a simple simulation of what happens when we try to run the code. Okay, now before we actually get on to the part about doing the demo of this presentation, I think it is worth noting that when we are representing our pins, normally we use board, but in this case we didn't use the GPI board. As you can see in this part, we have commented the GPI board because we are trying to use the PCM part, and you cannot run two GPIO modules at the same time, which means I can't use board and PCM at the same time. Now, the representation of each pin in the board and PCM is quite different, and one of the challenges that we faced when doing this project was actually figuring out how we can handle PCM, because in the class we learned about the board, not PCM. So in PCM we have pin 18. Pin 18 actually represents pin 12 in the representation of the actual board. Now let me just do a quick simulation of our intrusion detection system. So right now we're waiting because the program is kind of slow. So right now, as you can see, the program is running, but the status is false. Remember, I mentioned that the status is false if and only if the door hasn't been opened. That means if our ADXL hasn't moved. Now I'm going to just try and move the ADXL a bit, and as you can see, the status here has changed to be true. Now, after it has checked the status and found that it is true, it is going to check whether it's a human being or not. Now, it has recognized that through the camera, it has recognized this camera. It has recognized that there is an object showing, and then now it's sounding the alarm and also turning on the lights. It's going to do this 3 times, as I already mentioned before. And then after doing this, it's going to actually try to detect who the person is, the person who is actually inside the room. Now let's wait and see what happens when we get to that point. As you can see, now it's starting to identify who the human being is. It's identifying, and it's going to open a pop-up to start capturing the video, because it has to capture a video and show who the person is. As you can see here, right now it is detecting that the person is actually unknown. Still trying to detect the face, and the face is still unknown. So because so many times we didn't see any other face showing, we only just saw unknown. That is why the final result here is unknown, which means the person is not known. Now it says here a message has actually been sent to my line, to actually show that someone is trying to trespass or intrude. Now, as you can see here, the time here is 8:12 p.m. and it's the time right now, the time of receiving the message, which means the picture of the person who was trying to intrude has been taken, and also I have received the message that there is an intruder, and this is the name of the video that is going to be stored inside the computer. I can easily find it and see what the person was doing. So now if we come to this part, this is the video, and I'm going to play it. This is what was captured by the video when the person was detected. Basically, this is what our system does, and maybe later on we will do more modifications, but for now, thank you very much for listening.